Good morning dear students. In this video lecture, let's discuss about combinational logic circuit and half adder. Combinational logic circuit, a circuit that uses the combination of different logic gates are called as combinational logic circuit. Now, as the title says, the combination of different gates can be NAND gate, NOR gate, XOR gate. All these gates may be connected or they can be combined to produce complicated switching circuits in the computer. Now, this type of circuits, they merely depend only on the present input and not output from any previous state. Hence, they don't have the necessity to possess memory. So, these combinational logic circuits do not have memory. They use only and their output depends only on the present input. Now, look at here. This is a block diagram that represents combinational logic circuit. Now, left side we have input variables. We can give n number of input variables. Likewise, we may derive m number of outputs from the combinational logic circuit. Now, certain examples for combinational logic circuits are adder circuits, subtractor circuits, encoders, decoders, multiplexer, demultiplexer, comparators. All these circuits, they follow the principle of combinational logic circuit. Now, let's see about half adder. Now look at here, half adder. Half adder is a type of combinational logic circuit. Now once again remember combinational logic circuit, they do not possess any memory and their output merely depends only on the combinations of their input. Now look at here. Now half adder is a type of adder circuit. Generally the adder circuit, what they will do, they will be adding the given numbers. Now here comes a half adder, the special type of addition circuit that adds only two single bits. Look at here, two single bits with the possibility of a carry. The circuit that performs this type of operation is called as a half adder. Now let's look at the symbol for the operation of a half adder. Now just a block diagram which represents the operation of half adder. Half adder denoted by the letter HA. Now left side it denotes input and right side what we have is the output. Okay, right. Now since it is going to add only two single bits, only two numbers, it involves two variables. The variables can be either A or B. Okay, now look at here. The variable A can take the value either 0 or 1. Likewise, B can also take the value 0 or 1. It can take either A is equal to 0 or A is equal to 1, B is equal to 0 or B is equal to 1. Okay, any one value it can take. So our aim is to what? We are going to perform addition of the variable A and B with the possible combinations of their inputs. Okay, now their outputs are represented by S and C. C represents carry, C represents carry and S represents sum. So now sum represents what? The sum of two variables are given by the terminal S, and if there is any carry exist out of sum, that is denoted by the letter C. Right? So now we can say that the half adder is a circuit that involves two input variables and it contains two outputs. Two inputs and two outputs. Let's move on to the truth table. As the truth table reveals the function of logic gates, now let's explore. Look at here. Now let's look at the combination. Either A and B can take the values of 0 0 or 1 0, 0 1 and 1 1. These are the possible combinations of input variables. Now we have to find out the sum. When we add 0 and 0, obviously we get 0 and there is no carry, so here it is 0. Now when we add 1 and 0, the sum is 1 but there is no carry, so it is 0. When we add 0 and 1, we get sum as 1, there is no carry, which is denoted by 0. When we add 1 and 1, we get sum as 0 and the carry as 1. Okay, so the truth table represents the function behind the circuit. Okay, right. Now let's let's have a view on the sum. Look at the view on the sum. Now as you look at here, we have got the higher output. Okay, when we get the higher output, look at here, let's focus on the two inputs. Let's look at the two inputs, two outputs, this one. Okay, so we get the higher output. When do we get the higher output? When only one input is high. Now I'll say that the sum, okay, the sum is the output sum follows XOR gate, isn't it? You remember the XOR gate gives output when only one input is high. Hence I say that A XOR B. Okay, the sum, as the sum follows the logical function of XOR gate, it is given by S is equal to A XOR B. Okay, so what we have done from the truth table, we are forming the Boolean expression. Now the next one is what? We are going to draw the logical diagram. Now for carry also we have to look at the carry. As we move from the first bit to the last bit, look at here, it gives you output when both of the inputs are high. So this output, the carry, it seems it follows the logical function of AND gate. So I can write here C can be written as A dot B. Okay, so now actually what we have done, we have obtained the Boolean expression for sum and we have obtained the Boolean expression for carry. Now with the use of this Boolean expression for sum and carry, we have to draw the logical diagram. How to draw the logical diagram? Look at here. Here also it involves two variables and here also it involves only two variables. Now let me take two variables. Let us name the variables as this is A and this is B. This is A and B. Now XOR gate, what is the way to draw the XOR gate? So here we have a contact. This is B and this is A. Okay, what is the way to draw? This is the way to draw the XOR gate. So what will be our output? Output will be what? This is S. S is equal to A XOR B. Likewise, what for carry also we have to draw the logical diagram. Now this is AND gate. This is C. This is XOR gate and this is AND gate. This is sum and this is carry. C is equal to A dot B. So here the output of XOR gate is the sum. The output of XOR gate is the sum and the output of AND gate is the carry. Okay, this is the way to implement the half adder. It's the way to implement half adder, or it's a way to design the half adder circuit.